going to look at how a matrix inverse and a system of equations might relate to each other. Let's start by considering this general system of three equations with three unknowns. We can actually rewrite these in terms of matrices. So we can rewrite this as the coefficient matrix times the vector that contains x1, x2, x3 is equal to my b1, b2, b3 vector. And if you actually multiply out this left-hand side here, you will get back to the system of equations. If you multiply out the left-hand side, the first row would be a11x1 plus a12x2 plus a13x3. And then on the right-hand side, we have that's equal to b1. And that would continue down. This is called the matrix equation, and a lot of times we see it written as ax equal to b. Matrix A times vector x is equal to vector b. So from now on, when we're dealing with systems of equations, we will refer to them as this ax equal to b. Since we want to see how this relates to invertible matrices, let's suppose our matrix A is invertible. We already know the matrix equation can be written as ax equal to b. Since A is invertible, I can multiply both sides by A inverse on the left. The left-hand side then reduces to the vector x, the right-hand side reduces to A inverse b. So if A is invertible, not only does a solution exist, but it's unique. We can find it by multiplying the inverse by our b vector. So this actually proves a big theorem, that if A is an invertible n by n matrix, for every possible n by 1 vector b, so it doesn't matter what the vector b is, the equation ax equal to b will have a unique solution, and it's given by A inverse b.